All right, in the previous sequence we talked about how to write a sequence, how to fill that sequence with the electrons, correct number of electrons, and from there we transform that sequence into a picture. Okay, fill the nucleus and the orbitals with appropriate number of electrons. We even label what those orbitals are. But before that we learned the elements in the later rows, and we had to do some switching around. Now normally it's taught a different way where you would end up with the sequence, but still you have to make some changes to it to understand it, and that is a concept that's really hard for students. So let's pick a different element in the periodic table. Let's say we pick cobalt, which is CO. Okay, CO for cobalt. Okay. Now if you look at the periodic table and look at the atomic number, cobalt's got 27. Okay, that's the atomic number. And again, we're building on every time we're learning something. So 27 means it's got 27 protons and 27 electrons, right? Now we're developing the sequence primarily for the electron. Let's go get our blue and write our sequence. Now if you go, as I said, they could have fixed it in the first place when they built the periodic table, but maybe chemists, we want to be tough to our students, so that maybe we want them to go through the struggle just like they did. I didn't create the periodic table, so maybe that's part of the theme, I guess, is to struggle to learn chemistry. Maybe things were not meant to be made easy in the first place. Anyways, cobalt is following that 4s. Even though it's in the fourth row, it gets a 3D designation. So we still have to get through those top 3 rows and the fourth row to get to our destination, right? So that means we got to go to 1s, 2s, 2p, 3s, 3p. If you see, the arrows point you where you go from one to the other. After 3s, you got to go to 3p, and then you go to the next row, 4s, and then 3d. Okay, now you got 27 electrons, so we do have the freedom of randomly start filling things. Now keep in mind, an s orbital can only hold a maximum of 2. This 2, p 6, s again 2, p again 6, s again 2. Now what do? We stop and start counting. 2 plus 2 plus 6 plus 2 plus 6 plus 2. That would be 10, 12, 18, 20 electrons, right? I think I did my math right. Yep, 20. That means how many more do we need? 7 electrons, because our target right here is 27, right? Now we got our 27. If we add 7, that means we go and add 7 here. Okay? Now here's where the tricky part is. I'm going to give it maybe another color, maybe a black. Okay? Now keep in mind, the orbital, even though this is the way it's designed, ultimately the 3 should join with the 3. Okay, ultimately. Okay, that's what we're trying to do. So we're going to move this whole thing in the forward, the last 2, whatever the last 2 is. Now this is something I came up, I wouldn't give myself entire credit, but as I start teaching, I find this very helpful because this is foolproof. There's no exceptions to it, and you're always going to get this right. Okay, so I wouldn't say I discovered it. I don't think I can discover anything, but I've taught this multiple ways over the years, and I found that this is the one method where there's no exception, means you always will get it right no matter what. So move the last one forward so the 3 is next to its counterpart 3p, and 4s is outside. You can call it an outlaw. So let's rewrite the whole sequence first. Okay, where we got our 3D back with its regular family of threes, and the 4s comes outside. Now you don't change anything, particularly for the 3D. The D carries with it at 7 and the S carries with it at 2. So now this right here, fellas, this is the corrected and accurate configuration. Now if you want, you can create and send me pictures of your work. You can take a screenshot, save it as a file, send it to me by email saying, hey, see, I created those beautiful Da Vinci type of drawings for this long sequence. You're welcome to do that. That shows that you are the person that goes that extra mile. Okay, but for typically later ones, I expect you to do just a regular sequence, and that's perfectly fine. All right, so let's stop and let's do one more, and I'll have you practice one more while you're watching a video.